Good afternoon, guys. Today we are back with another problem. Before I start this problem, make sure you guys like, share and subscribe to the channel. Today's particular problem statement is given a permutation of first natural numbers in an array, and we have to determine if the array can be sorted in exactly two swaps. So this is our goal of the problem. We have to sort the array in exactly two swaps. And what is a swap? A swap can involve the same pair of indices twice. A swap can involve the same pair of indices twice. So let us try to understand this particular problem statement with the help of an example. So we can see that we have been given the array 4, 3, 2 and 1. The output is true. Okay, so let us see how we can sort this particular array. So right now, let us first write the indices of the array 0, 1, 2 and 3. Okay, so if I am swapping the fourth position, what is the original position of the fourth position? Fourth position should be lying over here. So first we have to determine the index of this particular position. So if it is 4, that means it is in natural order. That means it is lying at ARR of 4 minus 1. That means ARR of 3. So I am swapping ARR of 3 with particular value 0. Okay, with particular value 0. So if I swap this value, what I will get 1, 3, 2 and 4. Okay, after that I will perform another swapping operation. Right now my counter has moved to this place. Over here at this particular point I am having a 3. So what is the original place of this 3? The original place of this 3 is nothing but 2. Okay, original place of 3 is nothing but 2. So I am swapping 1 with 2. So I will get 1, 2, 3, 4. So now you can see that this entire array is sorted. So it is sorted with total of 2 swaps. Means one operation over here and one operation over here. So the array is sorted in 2 swaps. Now let us check the algorithm. We can check that if the array of I is at I plus 1th position, that is what I have told you. Swap if it is at correct index. Keep the track with the counter. And if the number of swap is greater than 2, then we can return false because we have to do it in exactly 2 swaps. And if the number of count is 2, then we can return true. Okay, so let us try to understand this problem with the help of a try run. So in the array, what you can see 4, 3, 2 and 1 is present. So at the first counter, array of 4 is there. Okay, now what is the correct position of 4? 4 is correct position is 3. So I am replacing 3. So I can get my new array as 1, 3, 2 and 4. So if it is done using one pass, that means my counter has become 1. Now I'm coming to the second part. Over here my I is at first position, and what is the element present at the first position is 3. So if 3 is present and 2 is where the original position of 3 should be, because 3 should be over here before 4. So I will pass another operation and it will swap and give me 1, 2, 3, 4. Now my array is sorted, so count is 2. Now let me go till I equals to 2. In I equals to 2, I have to check whether there is any other possibilities. So at I equals to 2, 3 will be at its original position. So there is no swap involved. So I can write count as 0. At I equals to 3, the swap is at 4th position. So in 4, it is placed at the original position. That means no swap. So the highest value of counter received till now is 2. So what I will say, okay, so this is true. That's how we are going to solve this problem. So let us analyze the code. First, we are making a Boolean check function. We are passing a list as our array. We can even pass an array. We are keeping a count. We are checking the count. We are iterating through the array from the first position till the end of the array. We have passed a while condition. While condition is checking that whether the array.getI means the value present at that particular position is not equals to I plus 1th position. Say for example 1, 2, 3, 4 is there. So if I array.getI, so imagine array.getI is 0 means this value, means this value, okay, means this value. So 1 not equals to I plus 1, 0 plus 1, okay. So 1 not equals to 1. This is not 1 is equals to 1, right? So there will be some other values. Till that time that value doesn't become equals to that, does not become equals to the indices, we are going to iterate it. Okay, we are going to iterate it. Int num. So in this case, the loop will end over here. In this case, the loop will end over here because at this position it will become equal. At this position it will become equal. Okay. So in num, what we can see, we are getting the array of I. Array of I is nothing but the particular value -1. So we are doing -1 so that we can say that right now at I, say for example my num, okay, num equals to array of get I is 1. Okay, 1 minus 1 is nothing but 0. Okay, 0. So while I'm getting 0, so I'm temporary value I am storing the array.get 0 means the first position. What is 0 means? The first position value at 1. So over here I'm getting 1. Array.set num comma array of get I means 1. In place of 1 I will put get I. Get I is nothing but the value which I want to replace it with. And again I can see set I dot temp means I'm swapping. So this is how we can swap. This is how we can swap with the help of an array list. we have to use getter and setter methods. Once the swap is performed, we have to increase the counter. So we are writing C++. If the count becomes greater than 2, we will return a false. If the count is either 0 or 2, we are going to return a true. Okay. The entire process is taken by with the help of one loop. So we can say that it has a time complexity of O of n and space complexity as O of 1, as there is no extra other spaces required other than setting all these variables. Okay. So this was today's problem statement. Let us just run this code once so we can see whether it actually works or not. So this is the code. We can see array of get I not equals to I plus 1. If the num equals to array of get I minus 1, we have to use the swap function. We are taking the num, we are setting the num with the array of get I, and we are again setting it with the temporary variable. We are increasing the counter so that we can count the number of passes. We are going to submit this particular problem statement and see what is the update of the code. So it passes all the test cases. If you guys have felt like this problem helped you in some way, make sure you drop a comment and like and share to this particular channel. Thank you so much.